I just want to introduce myself and my co-host, Larry. My name is Bear Aksoy. I live in the DC area. I have been in the past a technical manager, and I've been in the Android development space, service side, started my career on the networking side. And recently, so I've been, since the beginning of 2007, I think, September of 2007 is when I found out about Flutter. I've been a Flutter enthusiast and been following it, keeping my hand on the pulse of Flutter and Dart ever since then. Recently, about 2 years ago, I've actually switched gears and I'm now in the cloud and in the integration space. I work for Salesforce as a senior technical consultant doing integration, but I am always still keeping, try to keep up with Flutter and any kind of mobile development. And I have with me my co-host, Larry. Larry, would you like to introduce yourself?
Hi, my name is Larry Eason, and I'm acting as the moderator tonight, so I'm trying to allow everybody in as quickly as I can. Thanks for joining this Zoom session today. I'm glad to have everyone here and glad to have our special guest, Andrea, with us today. Hope you enjoy the presentation.
Cool. So this will be recorded and it will be put on YouTube. We will probably put the link of the recording to the meetup page at some point. So without further ado, I would like to give the floor to Andrea. Andrea, why don't you take it away, introduce yourself, and we're looking forward to a great presentation from you.
Cool, thank you. Yeah, thank you very much for the introduction. And hi, everyone. Welcome to my talk about Firebase Cloud Functions. I think just a couple of announcements before we start. I suppose if there's any glitches with audio and video, let me know in the chat. But other than that, I'll be carrying on. And as I said, yeah, thank you for taking the time to watch my talk today. I'm happy that you've chosen to look at it. I just noticed that today was the same day as Apple's WWDC, so it's quite exciting that people are choosing to watch my talk instead. But yeah, I hope that I'll manage to keep you sufficiently entertained. And before I get to the main topic of the presentation, I just wanted to say a couple of words about myself. So I started using Flutter and making tutorials for the community around a couple of years ago. And as part of this, I created a YouTube channel as well as a website where I share tutorials about Dart, Flutter, and Firebase. And in these 2 years, I've had the chance to use Flutter in various client projects and also in a variety of demo apps that I made available with my tutorials. So today's talk is about Cloud Functions. And the reason I chose this topic is that many developers are already using Firebase as a backend for their Flutter apps. And in this context, I feel that Cloud Functions can really expand the scope of what you can do. So in my experience, Flutter, Firebase, and Cloud Functions are a great way of doing full stack development. So the way this talk is going to work is that I'll give you a brief introduction about Cloud Functions, and then we'll look at the various types of Cloud Functions that you can create, as well as a few code examples so that we can better understand when and how to use them. In particular, I will focus on background triggers and HTTP and callable functions. And to be fair, Cloud Functions is a very broad topic, so I can't really cover all of it in just one talk. But I thought I'd just give you a bit of an introduction and cover some of the things that I feel are interesting and some of the bits that maybe are not covered so much on the documentation. And also at the end of the talk, I'll leave some references so that you can explore the topic a bit more in detail. So yeah, and we'll have questions at the end as well. But I guess to start, we can have a definition. So what are Cloud Functions? And a good one that I found, a good definition I found is that they are a way to write your own serverless event-driven backend. So serverless means that you can use them to deploy your backend code without having to provision any servers. And Cloud Functions have a few interesting properties. They automatically scale based on the load, like you would expect from a Firebase product. And they also have strong security built in and also some other useful capabilities. In terms of pricing, you only pay for what you use, and this is based on the total execution time for all your functions. And the bottom line, I guess, is that they offer a great development experience because you can focus on what matters, which is writing your backend code. And before we go into more details, I think the most important distinction that we need to be aware of is that there are two different products here. One is Google Cloud Functions, and the other one is Cloud Function for Firebase. So as I said, there are two completely different products. They have separate websites and entirely different sets of documentation. So since we are most likely to build Flutter apps using Firebase, then the one that is relevant to us is Cloud Functions for Firebase. But yeah, just keep in mind that this is part of a bigger platform, which is the Google Cloud Function one. And so for the rest of this talk, I'll be talking specifically about Cloud Functions for Firebase. And I guess the first concept that we need to understand is that Cloud Functions are triggered in response to events inside Google Cloud Services, including any Firebase products that you may be using. So when you use Cloud Functions, your code runs on Google servers, and that keeps your application logic centralized and safe. So just to give you a few examples of things that you can do with Firebase Cloud Functions, you could set up an authentication trigger to send a welcome email when a new user signs in. Or you could, for example, receive an email or a Slack notification when a new issue is discovered in Crashlytics. Or generate a thumbnail when a user uploads an image to Firebase storage. You could moderate or remove any offensive words that are entered by a user inside your app. Or you could also do things like send FCM notifications to users. And these are quite useful, for example, if you're building a chat application. But you can also do things like indexing your Firestore database and implement full text search by tapping into external services like Algolia. So I'll show you some code with examples later in this talk. But before I get to that, I think we need to talk about Node. So Node is a runtime that allows you to write JavaScript code that runs on the server. It was introduced in 2009, and it has become very popular because it allows developers to write full stack applications using a single language, which is JavaScript. So since Cloud Functions run on the Node.js runtime, we need to write Cloud Functions in JavaScript or a language that can be compiled to JavaScript. So if you're writing Cloud Functions for Firebase, the only languages that are officially supported are JavaScript and TypeScript. Though I should mention that there is also an unofficial Dart package that you can use to write Cloud Functions in Dart. So you can find it on pub.dev at this page. And yeah, if you're feeling adventurous, you can give this a go. But for the most part, if you want to use official packages, then you need to be using JavaScript or TypeScript. So with that out of the way, we should maybe talk just briefly about setup. So in order to write Cloud Functions, you're going to have to have Node installed on your machine. And you'll also need the Firebase client, which is a command line tool that you can use to manage and deploy your Firebase project. So I won't be covering all the setup steps in this talk, and I'll leave some more links at the end so that you have everything that you need. But for now, I think I'm just going to show you a quick Hello World demo, and that is a good way to show you how you create a simple project and also how kind of things fit together. So just one sec. All right. Okay, all good. So yeah, so over here I have a Firebase project that I created from scratch. It's got pretty much nothing in it. It's just an empty project called Hello World. So you could create this from the Firebase console if you wanted. So what we want to be able to do is to configure this so that we can write some Cloud Functions for it. So here I just have a terminal prompt. And here, for example, I could create a new folder and call it Hello World. And I can cd into it. And then once I have the Firebase client, I can type Firebase in it. and this will configure the project with Firebase. This is an interactive prompt that is going to ask us a few questions. So the first one is to choose which features of Firebase we want to use. So since this is just a simple Hello World application, I'm just going to choose functions. Then we have an option to use an existing project or create a new one. So if you have already created the project, like I've done in this case, you can go here. And then I have to find it over here. And then you get to choose which language you want to use. I think TypeScript is better for a number of reasons in terms of type safety and other features that it has. So up until now, I've been writing my Cloud Functions with TypeScript. And then we can also enable TSLint, which will help us catch additional, potential bugs in our code. And then the last step is to install the dependencies with NPM. NPM is kind of the equivalent of pub if you're using Dart. So that's what you use to install dependencies in JavaScript land. So once this is complete, I can open up a Visual Studio Code instance on the project that I just created. And the next thing that I think it's good to look at is the project structure. So when you create a Firebase project this way, you're gonna have, if you selected Cloud Functions, you're gonna have a functions folder. And the most interesting file maybe that you want to look at initially is this one. So it's called package.json. And this is the equivalent of your pubspec.yaml file. So this is where you would install your dependencies. So there are a couple that NPM has already installed for us, which are Firebase admin and functions. We will look at this a little bit more in detail. And in general, what you would have to do if you wanted to install new things would be to go here and type npm install, and then you choose one of the packages that are available from npm. Once you do this, then the package will appear here, and it will also be installed inside this folder, which is called node modules. This is a folder that contains a ton of dependencies, but you don't have to manage this yourself. npm does it for you. So this is something that you don't want to modify, and typically you want to add it to your gitignore file. So that's the package JSON. Along with that, we can take a look at the source folder, which is where your main application file lives. By the way, before that, I should also point out that there's this section called engines, and it says node 8, which is what is created by the standard template. If you create Cloud Function projects, make sure that this is set to 10 because node version 8 is getting deprecated. So just one little tip to know there. There's this main key here, which points to lib.index.js, which is what our application, what our Cloud Functions will compile to. But since we are writing TypeScript, the main entry point for us is under source, and it's called index.ts. And this is just your standard Hello World application. So how does this work? It looks like this by default. So at the top, we are importing the Firebase functions model. And then we make it available as a functions identifier so that we can use it here in our code. And then the first thing we do is we export a function called Hello World. This is defined as an HTTP type function that responds to a web request. So this gives us a request and a response parameter. And these are object types that come from express.js, which is a web framework that you can use to, for example, to write REST APIs. And then all we do in the response, in the body, is to just send this string back to the client with response.send. So the bottom line is that this function responds to all incoming HTTP requests by sending always the same canned response with this command. Once you have this, what you can do is to deploy it. So you can go into your functions folder, and then you just type in Firebase deploy, like that. And this will, just compile all the code from TypeScript into, in this case, into JavaScript. And then once that's done, it will, just deploy the function onto Firebase. And when it's finished, it will give you a URL that you can use to point your browser to get access to that function. This may take a few seconds, so I'm just going to skip this because I've already kind of done it beforehand. But once the function is deployed, if you go on the Functions tab in Firebase, you're going to be able to see it here. So what you can do is take this URL, you can copy it, and then if you go on a new browser tab, you can enter this. And if my Wi-Fi is happy, so it just runs and prints back the response that we set on the client. Okay, so this is kind of the super basic example that I thought was at least useful to cover for the ones of you who might have never used Cloud Functions before. But I think we can look into something a bit more interesting now. So we managed to deploy our first Cloud Function, just 1 second. So we have just managed to implement an HTTP trigger, which is something that can be called directly by the client by making a REST API call to the Cloud Function URL. But there are also other types of background triggers, and these are different in that they are not called directly by the client application, but instead they are triggered when something happens. So we could broadly divide Cloud Functions in two groups, background Cloud Functions and Cloud Functions that are called directly. So within this second group, we have standard HTTP requests as well as callable Cloud Functions. We'll take a look at the difference between HTTP and callable a little bit later, but the general idea is that the client calls the Cloud Function directly, and this in turn could access some data in Firestore, do some computations, and send a response back to the client. On the other hand, background triggers are maybe more common. And for example, a very common flow here is when a client app writes something to Firestore, and this triggers a Cloud Function that updates some data according to some server-side logic. So this Cloud Function could then write back to Firestore, and then the client app can listen to changes in real time. So in this scenario, the client app only talks to Firestore and doesn't care or doesn't even know about Cloud Functions running in the background. So to give you an example of background triggers, I prepared another demo. So let's take a look at the code for this. And in fact, before I show you the code, I should show you what it is. So the demo is a restaurant application where what you want to do is to be able to rate restaurants. And by doing that, we're going to have some Cloud Functions that will calculate, for example, the average rating for a restaurant. So this is something that is useful in a lot of different apps. You can use it, as I said, for restaurants. You can use it for things like, say you have a movie database, you want to rate movies or books or online courses, anywhere where you might want to do in-app rating. So the idea here is that in Firebase, in Firestore, I have a top-level collection called restaurants. And inside it, I have a number of restaurants, and each one of them has a name and optionally this rating and the number of ratings. So the idea is that users can see the list of restaurants. This is obviously a very bare bones application. You would probably have a lot more content in it and more details about the restaurant and whatnot. But just for the sake of doing the in-app rating, the idea is that you can see the list. And then, for example, you can drill down into a detail screen. And what you do here, for example, is to rate a restaurant. For example, I'm changing the rating. And what happens when I do this is that I'm actually writing the rating into a sub-collection for that restaurant's document. And I'm using the currently logged in user to reference that rating. And what happens is that when any of the documents inside this collection changes, then a Cloud Function is triggered, and that will recalculate the average rating and the number of ratings. So this is not something that we can or should do on the client, because clients should only have read-only access to the restaurant data in this case. And the only thing that the client can write is the rating value for a signed-in user. And instead, the logic for calculating the average rating should live on the server. So this is a good example of how we might do this with a Cloud Function. And if I show you the code for this, over here I have the same function, the same package folder structure that I was showing you before, but this time inside my index.ts, I export a function called update restaurant rating. This is triggered when there is a write event to a Firestore document that matches this specific path. And just to be clear, when we define a Firestore trigger, we can choose between on create, on update, on delete, and on write. And on create will only be triggered when the document is first created, whereas on update is only triggered when the document is updated. So in this scenario, I want my users to create a rating as well as update it later on. So to catch both on create and on update, I can use on write, and this will give me a change object. This object is something that I can use to see the content of the document snapshot before and after the change. So what I'm doing here is to call this internal update rating function that I created. And then what I'm doing is to get a reference to the restaurant ratings collection, which would be the parent of the rating that I've just changed from the client. And then what I'm going to do here is to list all the documents and then just do a loop where I can go through all the documents and I can, essentially just calculate the total and the average rating as well as the number of ratings across all documents. And then after I'm done with this, what I need to do is to get the reference to the original restaurant document. And this is the one that you kind of see over here, which has these properties, right? So once I had this, I can call an update method and I can pass along the new values that I've just calculated. So this is how you would implement the Cloud Function for this. And once again, I could show you like a runtime, how this works. So I can go onto a different restaurant and here I could, for example, change the rating and submit it. And you can see that it kind of took maybe a second or two to update. And the reason for that, and this is something that is worth being aware of, is that when Cloud Functions are not used often, they go through a cold start. So this means that because Cloud Functions are stateless, sometimes the whole environment needs to be set up so that a Cloud Function can run. So when Cloud Functions are called infrequently, you are more likely to get cold starts, and so the execution time can take longer. But on the other hand, if you have a live app with a lot of users, then your Cloud Function may be called more frequently. And in that case, you will experience fewer cold starts. So this is just something to be aware of. But in any case, I can go back to the code. And one thing that I can point out is that this function that I created is asynchronous. And in fact, I have a number of await calls inside the function body. And this is the same pattern that you use in Dart when you do await and async. But the important thing to remember here is that, Cloud Functions work with promises, which is, again, in Dart would be a future, but it's the same concept. And we should keep that in mind. And the other thing that we should keep in mind is that we should only ever return from a Cloud Function when all the internal asynchronous calls have completed. And that's because when a Cloud Function returns, it can be shut down by the server instance that is running it. So by awaiting on all these asynchronous operations, we make sure that we really complete all the tasks that we need to do before we exit the Cloud Function. The other thing that I want to point out is talking about the Firebase admin SDK. As you can see at the top here, I'm importing this Firebase admin module, which I'm kind of referencing as admin. And the first thing that I do here is to call admin.initializeApp. And this is something that you need to do in order to set up Firebase with all the correct settings for your project. So in this example, and you can do other things with the admin SDK as well. So in this example, we have made changes to some collections and documents just by going through the references that we retrieved from the change object. But if you use the admin SDK, you can actually access any collection or document that you want with a syntax that is a bit like this. So you could just call admin.firestore. For example, document, and then a specific path to get access to that document. And this, when you do this, you get full read and write access to that document. So the very important thing that you need to know is that Firestore rules don't apply when you use the admin SDK. And this makes sense because Cloud Functions run in a secure environment. And instead, if you run code on the client, you had to adhere to the Firestore rules. So that's, again, something else that you need to be aware of. And there's a difference there between the admin SDK and the client SDK. Okay, so we have seen now how background triggers work. And then I'm just going to go back to the presentation that we just covered. And yeah, so the other thing that I want to talk about is to just get back to the HTTP triggers so that we can see how to use them and when they might be useful. And so just as a reminder, HTTP triggers is what we use when our client needs to call a Cloud Function directly. And this, yeah, as I said, this could call into Firestore, do some logic, and return the response back to the client. So when exactly would we want to do something like this? And there's a few examples. One of them, for example, is if you want to join data from multiple Firestore documents, and it is too complex to do this on the client, then it might be better to do this with Cloud Functions. Another reason might be that the security rules that we would have to set up are too convoluted to be done on the client. So again, that's another use case for an HTTP function. Other reasons is that we simply might not want the data to be accessible to the client, and it's just safer to process everything server-side before returning a response. An example of this would be, for example, coupon validation. So let's say that you have a coupon system where users can try to redeem coupons, and we want to be able to validate coupons only on the server before they can be used. So all this logic is much safer on the server, and the client, all the client needs to do is to call a Cloud Function to validate a coupon and check the result that comes back. So if you find yourself in any of these use cases, then an HTTP or a callable function is the way forward. And in fact, maybe I should, this is now a good time to talk about the difference between HTTP and callable functions. So first of all, the syntax is different. Up until now, we have seen on request, which is how you create an HTTP function. If you want to create a callable function, you have to write .onCall. So what are the differences? HTTP functions are good, for example, if you want to implement a REST API. And if you go for this approach, it means that on your Flutter app, you can use for example, the Dart HTTP package to make a standard request and then get a response and parse the JSON data. On the server side, you will get a request and response object. So you can use express.js to, for example, read the data from the request and also send the data out with the response. It is hard, it is tedious to do a lot of things with HTTP Cloud Functions because we will see this, but yeah, they involve a lot more work on the client and on the server as well to do things like authentication. And in general, they tend to result in a lot more boilerplate code. So the way this is solved with callable functions is that we have a client SDK So the client just uses the SDK, which does a lot of the heavy lifting for us. So this makes it a lot easier to work on the client if we use callable functions. On the server side, they give us a context object, which again has a lot of the useful things that we might want to check, including the authentication data. So that makes authenticated requests a lot easier. And the bottom line really is that whenever you can, 99% of the time, you're better off going with callable functions. And I think just to maybe show you in practice how this works, I'm gonna show you another demo. So what I have here is a different app. I'm just gonna actually show you the database first and also the client. So the way this works is that it's a very simple top tips app. So the way it works is that over here on the database, I have a number of tips about best practices in Flutter, just to make a simple example. And what happens is that here I have two buttons on the Flutter app, and when I tap on any of them, now it's going through a cold start. So you see that it's actually taking a bit of time. But what it does is call the cloud function. This in turn will choose one of these tips at random, and then it will return the response back to the client. And the same goes for the callable function. They do the same thing. So what we're going to do now is to look at the differences in how these are implemented with HTTP and callable functions. So if I open the project, again, here we're going to have an index.ts file at the top. We're going to initialize the admin SDK. And we have some authentication logic, which I'm going to show you a little bit later. For now, I just want to focus on how we satisfy the request. So at the top, we have a cloud function called getRandomTip using REST. This is an HTTP on request cloud function, which takes request and response arguments. And what we do here is to call this common function that I called getRandomTip. And the second function is very similar, but this time is a callable function. And the arguments are different because we get a data argument and a context. But the bottom line is that both of them call the same thing. So if I open this, this is actually really simple. It's just to show you the difference. So what it does is to get the collection of tips from Firestore. And then I just select a random index. I pull the document for that index inside the collection. And then I return this back to the caller. So the difference here, though, is that when I implement this using the HTTP function, to return a response back to the client, I need to say response.send with the resulting data. Whereas with the callable function, this is actually a lot simpler. All I had to do is just to return the data at the end. So this is how things look on the client side. And now that I show you this, I think I can show you the client as well. So let's see how this might be implemented. Well, we would have a main file. Inside here, I have this home page, which is the one that you see over here. It's really simple. I'm just doing here bare bones code that you will need just to prove the concept. So these two buttons are actually implemented inside these API buttons widget class. And they're just, yeah, two raised buttons inside a column. So the interesting bit is that when we press the buttons and we hit the button callbacks, this is where we make the requests to the cloud functions. So in this case, with the REST API service, I have a provider that I've instantiated at the top of the widget tree. And this gives me access to this REST API service. I'm getting an access token, and I will talk about this a little bit later. And then what I do is call this method inside the REST API service. And as I was saying before, this is something that uses the Dart HTTP package. So what I'm doing when I call this method is to get the URL that I need in order to call the Cloud function. And then I can make an HTTP request, pass in the URL, and then I need to pass some headers. Once this request is complete, I get a response. And typically what I want to do is just to check if the status code is 200, which means everything is okay. And I can just decode the JSON body and return a top tip, which is a data model class in this case. And this is also where you would put any exception handling code. So this kind of works, but there are some things that are not so nice about it. If I scroll up a bit, what you will find is that, for example, you need to explicitly set the base URL that points to the Cloud function URL. And this is not great. And it's actually even worse if you have multiple flavors in the app and you want to connect to different Firebase instances, depending on whether you're running on dev, staging, or production. Then you're gonna have to do this kind of switching logic and just so that you can get the base URL for the correct environment. So this is a lot of boilerplate code, and it's kind of repetitive to have to do this. On the other hand, I can show you what the Cloud Functions version of it works if we use callable functions, and this is a lot simpler. At the top, we just import Cloud Functions.dart, which is a package, one of the Firebase packages for this. And then it's actually a lot simpler. All we have to do is to get the name of the function that we want to call. So in this case, this is how it's called in the Cloud Functions folder. As you can see, like here, we don't really need to worry about URLs and environments, none of that stuff, because the Cloud Functions SDK does all of that for us. So it's a lot easier to manage. If we wanted to pass in some arguments that our backend code will process, we can pass them here as a map. But the essence of it is just that we call this with an asynchronous call. We can get the result and we can parse it just in the same way as we did before. So yeah, this is a lot simpler. Just quickly, if I show you the pubspec.yaml file for this project, if you opt for the REST API solution, you could use HTTP or another Dart package that you might want to choose for networking. And if you want to use callable functions, you just need to import Cloud Functions in this fashion. So I guess the bottom line is that we can save a lot of code by using callable functions, but there is more as well, because when I was showing you the REST API setup over here, I was getting this token, and this is something that in turn is passed on to the authorization header. So this is actually how you do kind of authenticated requests traditionally with REST APIs. You just get a token and you can pass it on like this. In order to enable this, you need even more boilerplate code, because you had to get the current user from Firebase auth. Again, this is not code for production. I'm just showing you the idea. But yeah, you need to get the user, then you get a token from it, and then you return this object, and then you have to pass it down to the REST API. So it is a lot of extra steps that you need to do. And it is a lot of extra steps, not just on the client, but on the server as well. This code that I previously commented kind of goes like this. So if you pass the authentication bearer from the client, this will come through into your request object. And what you have to do if you want to do authenticator requests is to parse this. And you kind of have to write all of this stuff manually. So this is just code for extracting the correct token from the authorization headers. And yeah, it's just quite a bit of extra boilerplate code. Once you have the token, you can then call this function on the admin SDK to verify the token. And from here, you get a decoded token, which is what you might use to get the user ID. So again, this is quite a lot of stuff. On the other hand, if you use the callable version of it, it is a lot simpler. Like all you had to do to check if the user is authenticated is just one if statement. And if you don't have a node object inside your context, all you had to do is just to throw an HTTPS error, and then you can catch this on the client. So again, authentication is a lot simpler. And just to show you that in practice how this works, I can actually log out of this application, and this takes me to another sign-in screen where I have the same buttons, but this time I'm not an authenticated user. So if I try to call this now, I get 401 status code for the REST API, and I also get an error on the Cloud Function. So that's how you do authentication, essentially. Okay, so let me just go back to the slides. Yeah. So yeah, up until now, we have seen 3 different examples. Hello World, just to start with, we have seen how to implement a restaurant rating system using a background trigger. And we have also seen some random Flutter tips app, both with HTTPS and callable functions. But what else can you do with Cloud Functions? And yeah, the answer is that you can do really a lot of things. And for this, I think there is a great resource that I've been using a lot when I was learning about Cloud Functions. This is a collection of samples from the Firebase team. And they just cover probably 90% of the kind of things that you would want to do with Cloud Functions. It starts with some simple kind of things, just to get the idea of how this works. And then there are some more complex examples as well. So, and this will show you how to do things like sending FCM notifications, charging customers with Stripe or PayPal. It will do things like full text search with Algolia, which is what I was mentioning. I was actually planning to cover this in my talk, but I don't think in the end it didn't quite fit. So, but you can find the code for this on this repo directly. And so yeah, definitely this is a very good resource to have. What other things are interesting? There are maybe some best practices, which I'm not going to cover in a huge amount of detail, but maybe as we close up, just a couple of things to be aware of. One thing is that as you start building Cloud Functions, you typically have all your code in index.ts. But as your Cloud Functions folder grows, you don't want to have everything on one file. So what you can do is to start moving some of the internal functions into separate files. And then you mark these functions with export in the file that you want to import. And then inside index.ts, you just use this import syntax to get a reference to the function that you want to call. And then you call it like that. So yeah, I think the idea here is that imports and exports give you a way of splitting up the code so that you don't have everything in one file. The other, I guess, important thing that it's worth mentioning is that with Cloud Functions, because they can be used concurrently, it's a good idea to use transactions if you have multiple reads and writes. So this is something that you can do with the client SDK as well. So if you use Firestore in Dart, you can write code with transactions, but you can do the same server side. And it's perhaps even more important to do it server side because you can get a lot of concurrent requests from a lot of different devices. So it's important to try to keep your database in a consistent state. And the way to do that is to use transactions. I might even show you a very quick example of this in code. This is another project that I've been working on. Just to show you how you use transactions. The idea is that you get your Firestore object from the admin SDK, and then you call run transaction. This will give you an asynchronous function body. And so inside here, rather than creating or updating or reading documents in the way you would do before, you always do it through the transaction object that is an argument to this function. And then you just call all your methods like this. And the good thing about it is that the transaction is atomic, and that means that your all your call the calls either all succeed or all fail. So that ensures that your database is in a consistent state. So yeah, I think this is one thing that is worth keeping in mind. You kind of really need this if you have to do multiple things like this. And yeah, I mean, there are still many more tips that I don't actually have time to cover fully in this talk. But I think, sorry, I just lost my slide. Yeah, I think that there are many more things that I haven't really covered. But if you visit this URL, this is the source code for the restaurant rating app that I was showing you earlier. So in here, you'll find the source code for this, but you'll also find a whole bunch of links with kind of some material that you might find useful if you want to learn a bit more about Cloud Functions. So yeah, I hope that this will be useful. And other than that, I think we reached the end of my talk. So thank you very much. It's time for questions. I can see that the chat has filled up already quite considerably.
Yeah,
So,
thank you, Andrea. That was great presentation. If you want, I could read out some of the questions and let's see if we can answer some of them.
You can choose one to start with,
Yeah.
and then
Okay.
I'll see how I can answer it.
Okay, so it says, what happens if more than 2 persons update the rating concurrently?
If 2 people hit the rating concurrently, in terms of the write that the client does, because they will be 2 separate users, they will write 2 different rating values into 2 separate sub documents. But once I guess the cloud function will be triggered twice. So you would get a first trigger, and that's where, you know what, let me actually look at the code. I can see maybe there's a bug in
my understanding is, I think what he's asking is more of a generic question, is what if 2 people, what if there's a racing condition? In other words, there's 2 people updating the same record. How about that? What happens then? Last one wins, right? Last one would win?
Yeah, I think it's a good one. If you use your code, I guess, with transactions, you are at least guaranteed that, you know, the first update comes in and it's executed, and then the second update only starts once the first one is fully completed. So I guess an example where you might see this kind of scenario is, say, for example, on Twitter, you have the number of likes for a given user. So say you have 100 likes and another user comes in and does an additional one, and then another user does one more. You would get probably a trigger on the first one, which will read the current value, which is 100, and then we'll update it to 101. And if you do this with transactions, you're guaranteed that the second trigger would have to read the updated value, because it would only, I guess, enter that document with the value 101. But I think there are additional considerations. I mean, this actually works on a scale where all the data is kept just in a single location. So if you normally have just one database instance where this data is stored, so that's how it works. If you talk about networks like Twitter or Facebook, where they have like millions of records, it's likely that their data is also divided into separate locations. So I'm not too sure exactly how they implement that kind of behavior. But at least if the data is just in one place with Cloud Functions, you kind of need to do it with transactions. And at least you can guarantee that you're going to do read and write for the first trigger and then read and write for the second trigger. And that way you keep them in sequence.
So the answer to your question, Jay Rao, would be if you find that you're going to have a situation where there's some kind of a racing condition, you make sure that you write transactional code. So there's another question that says, it seems like it would be easy to accidentally write infinite loops if you modify a reference in the on-write listener.
That's correct.
What to do to safeguard against that?
Yeah, that's correct. So in the scenario that I've shown, it doesn't apply because we read from one location and we write to another one. But one scenario where this applies is, for example, if you're doing text moderation. So say that you're leaving a rating for a restaurant. you might want to replace all swear words. So if you say Coca-Cola is a swear word and you want to replace it with Pepsi, you can do that. And because you will be updating the same document, that would trigger an additional update. So you had to be defensive in your coding. And when you implement the cloud function, you had to basically check if basically you would have your text inside the document. That is the one that you want to change. What you can do is to check if the modified text is going to be different from the one that you already have. So it's a case of just adding a conditional inside your cloud function and make sure that you exit that loop. So and what you want to avoid is to write again to the same document location if the text didn't change. And that gets you out of the loop. It might work in that scenario. In a generic sense, I guess you just have to write defensive code. You just have to write defensive code. It's a little bit like when you have a recursion, like you're writing a recursive algorithm. You want to have a condition in there that gets you out of the loop.
Break out of the loop, yeah, exactly. So that goes back to basics of writing good code, I guess, right? So I have a different, Akil Raj says, I have different Firebase environments for development, staging, and production of my Flutter project. Since cloud functions are created by Firebase CLI, how do I go about deploying cloud functions to these different environments when building with CI/CD?
Yeah, so what you do is this, you type Firebase use, which is a command that shows you different aliases. So when you first configure your project, you would point to a specific Firebase instance. So for example, development. If later on you add a new project, which is your staging or production environment, you can do Firebase use and then --add, I think it's called. And that gives you a way to select one more project inside your Firebase console, and then associate an alias to that. So yeah, you can basically have multiple projects that are active and configured in your project, and then you can switch between them. So when you deploy, you can say Firebase deploy -p, and then you specify the name of the alias, and that's how you choose which Firebase instance you want to deploy to.
Okay. So Boris asks, this is more of a question outside of what we covered today, but if you have any just quick tip. I usually don't write flawless code in first run. What are your best practice for debugging remotely, locally, emulator, that kind of stuff?
Yeah, it's a good one. So cloud functions, for the ones that may not be aware, what I covered so far is like how you write it and how you deploy it. And once you have deployed it, there is a way that you can check what's going on, and that is by going into, so you have a logs tab, and this is where you can see everything that is happening. So all the functions that are being triggered, all the errors, all the functions that are being deployed, and this is where you see the logs. This is useful for monitoring in production, but when you're debugging locally, you don't really want to have that developer loop where you deploy and then check the logs and then go back to the code. It's very, very slow. So what you can do instead is to start up an emulator. So with the emulator, you can just call functions. There is basically like a REPL mode as well. So you can enter like an npm interactive mode. And what that lets you do is to have like an npm shell. And with that, you can call functions directly if you're running them on the emulator and pass arguments directly to them. That works if you want to kind of do command line type of stuff. It gets more complicated if you're, I guess, trying to debug an app that maybe you have running on the simulator already, because that app is configured to point to the Firebase instance where the code is already deployed. So I don't think I have an answer for that. But if you just want to do things locally, there are some good use cases for this. For example, sometimes you want to do things like database maintenance, and you want to check if say, for example, you are introducing new types of fields to your Firebase schema with a new version of the app, and you want to upgrade all old users to the new schema, you can write a function that will do all the update, going through all the collections and documents. And if you're just testing that functionality, you can start up a local emulator, which lets you run functions locally on your machine. The caveat is that you can then choose to either also have a local database, or you can have your local functions talking to the database on the cloud. If you want to do that, there's a thing that you need to do that lives in the project settings. There is a thing called service accounts, and that is what that lets you do is to create a private key that you can download. Then you can point a certain environment variable to that key, and that lets you use local functions to talk to the remote database. And there's some security considerations behind why you need to do it this way. I'm not sure if the links I shared already include this. I think, yeah, it's here, like manage function deployment, runtime options, and environment configuration.
Nice. Okay, great. So we're running over just a few minutes. I'm just going to see if we could maybe answer to whatever is left, or maybe at least one or two more. So Zilati Pehlivanov asks, one important thing you missed is the use of Firebase.json to specify rewrites.
Yeah.
So that your endpoints have different string than the name of your function.
Yeah, I guess that's, as I said, it was probably hard to cover everything.
Right,
but
okay.
yeah, it's a fair point. You have, I think it's in, I can't remember now. I think it's in Firebase JSON. There is, yeah, so if you don't want to call directly the URL that comes out of Firebase, which is the Cloud Function URL, you can set up a rewrite, and that helps you, especially if you are going to be calling these functions from the browser, because there's a thing called cross-origin reference. I forgot now what the acronym is like, but I'll tell you actually the best, well, I did write about it on like recently. So this is one of my recent tutorials where I cover, what is it? Yeah, handling cross-origin resource sharing and how that works and what you had to do to get around that problem if you are hosting your Firebase project with Firebase hosting.
Okay, great. So Mateus Perlock asks, any Dart to JS shortcuts, excuse me, to create the Cloud Function code from Dart file?
I don't know. I haven't really looked into that kind of thing. Like the closest I got to Cloud Functions and doing stuff with Dart was that plugin that I was mentioning. I think I got it somewhere here. So I don't know if that one lets you do what you're asking for. That's as far as I got on that one, sorry.
Yeah, that's fine. So Gurav Varma asks, I've recently used MongoDB Realm. This is quite similar to the webhook available there. Can we expect support for MongoDB Atlas at any time in the near future? Are you familiar with?
So I guess is the question around being able to have Cloud Functions talk to MongoDB or having some kind of Cloud Function triggers for MongoDB. I'm not sure.
Yeah.
I've never used MongoDB. I mean, one thing I would say is that Cloud Functions, because they are built on top of the NPM ecosystem, you can install any package that is available with NPM. So if there was an SDK that gave you access to MongoDB, maybe with some, I don't know, WebSockets or whatnot, then you could, as long as you can import that dependency into your Cloud Functions project, and then you can call into those methods. But that's as far as I know. Like, I don't know how in practice you would go about setting up triggers. Triggers are kind of tied into Firebase in a way. And I suspect anything outside the Firebase world, it's more a case of importing libraries and calling maybe REST API type kind of functionality, or maybe using WebSockets.
Okay, and the last question, Andrea, I'm not sure if I understand this, but maybe you will. Thanks a lot, Andrea. It seems Firebase Cloud Functions can completely replace REST API. Is that right? I don't think so, but anyway, even if I have a website version of, because they're apples and oranges, right? I mean, I think there's, but anyway,
Yeah.
even if I have a website version of my mobile app, I still can call these cloud functions, right? Question mark?
Yes, you can because the Cloud Function Client SDK is available in most languages. So you can, I mean, there's a Dart version of it. It's certainly available on web. In fact, when you create a Flutter web project, you need to import the JavaScript equivalent of the Cloud Functions SDK, and then you can call it in the same way. So the only reason why I would prefer using the REST API is if you're building a service for someone else. And in that case, you're basically building your own REST API for someone else to consume. But if you own your backend and you're building an app for yourself, then you have full control and there's no reason to go through all of that. You just use the Cloud Functions SDK and it's a lot simpler.
Mm-hmm. Okay, that brings us to the end of the presentation. And Zlati Pehlivanov thanks you. Says, great presentation, Andrea. Thank you so much. I've been using Cloud Functions for a long time. I learned something today from you about callable functions. I guess he wasn't using that. Andrea, thank you so much. Is there anything else you would like to add, Larry? Or we're wrapping it up, right?
No, I don't think so. That was very, very good. I actually learned a lot myself, and I wish I could have taken some notes, but I'll have to go back and watch the video again.
Watch the video. Yeah, we will be publishing this. So we'll make an announcement on the meetup page, right, Larry? With the link to the video, to the YouTube video.
We'll post it on YouTube and put a link up on the event page.
Yeah, and this so Andrea is a prolific publisher of material. I mean, I've been following your material for a while now, Andrea. You know, just a big thumbs up, kudos. Everything you do is top notch, 100%. And today's presentation was great. We learned a lot, I think, and we went a little bit outside of the regular, you know, Flutter discussions. It was something more useful and real, tangible that's applicable to the real world.
Yeah, I think that's why I actually wanted to give this talk because, you know, one thing about myself is that I've been like a front-end developer for like 8 years, and I've never ever touched any back-end code like until the last 6 months. And then I thought, okay, I know Firebase now. I started a project a few months ago where we had to do some Cloud Function stuff, and I started looking into it, and I don't think there's anything magical about it. Like it's again a library that is actually very well documented. The Firebase team has some really good videos about it. There's courses from other instructors that are really good. So there's already a lot of really good learning material there, and it's just a case of exploring it and trying it for yourself, like you would do if you're just learning Flutter, right? So, and the good thing about it is that once you know it, you can actually do full stack development, and that's quite empowering. That's quite cool. So that's, I think, why I wanted to talk about it.
Yeah, and I like that functions-samples, the website that's published by the Firebase team. That has some use cases that you shared earlier. Yeah. So, but yeah, so thanks a lot, Andrea. I really appreciate it. We all appreciate it. This was a great presentation. And so I guess people want to get in touch with you or consume your materials, Code with Andrea, right? Codewithandrea.com.
Yeah. So that's the website. Other than that, you can find me on Twitter. But yeah, I think if you go on my website, then all the links are probably at the bottom here if you want to contact me.
Exactly. Okay, everyone. Thank you for joining, and we look forward to seeing you all next time. Thanks.
Okay. Thank you, everyone. Have a good rest of the day.
Thank you, Andrea.